Welcome to this lecture. We will continue what we were discussing last time. Last time we were discussing that the software engineering practices have really evolved over the years, have become much more sophisticated. Now, let us look at some major differences in the way software is being written now. One is that the software engineering principles themselves have evolved, and the other is the software itself has evolved. The software writing problem is not the same as the problem that now we are solving. The problems have become much more complex, but at the same time these are only incrementally different from the problem that has been solved. Let us look at these issues now. The differences between exploratory style and the modern software development practices. Compared to 1950s or 60s, where the exploratory style was used, now the life cycle models are used. Every program is developed according to an adopted life cycle model, where there are a set of stages and the development occurs through those stages. The stages are typically the requirements analysis, specification, design, coding, testing, and so on. One major difference between the way program was written 1950s and 60s to now is that the emphasis has shifted from error correction to error prevention. The earlier technique, the exploratory style, was to first write the program, complete somehow, and then start correcting the errors. There will be hundreds of errors, keep on eliminating one by one until all errors are eliminated. But now the emphasis is error prevention. As the program is written, we track the errors and remove it from there itself, so that during testing we have very less number of errors to correct. Or in other words, as soon as we have a mistake committed by the programmer in program development, we try to detect it as close to the time of commitment of the error as possible. The main advantage of this is that it is very cost effective. If you correct the error after testing, then you will have to first find out where exactly the error has occurred, make changes to the code, again test, and so on. Here, before testing, we just identify the place where the error is there. We do not have to look at, we just look through or review the code and so on, or review the specification, review the design, identify the error, correct it there itself, and do not wait for the error to be discussed, detected and determined during the testing phase. The software is being developed through a number of phases, and in each phase, wherever a program commits a mistake, it is detected and corrected in that same phase as far as possible. In the exploratory style, program development was basically coding. Start writing the code as soon as the problem is given, but right now in the modern development practice, coding is actually a small part of the development activities. The major activities are specification, design, then coding, and then testing. Of course, lot of attention now is given to requirement specification. Then the design has to be done. There are standard design techniques that are available. and at the end of every phase reviews are conducted. The main idea behind review is to detect errors as soon as these are committed by the programmer. Do not wait for the error to be detected during testing. Reviews help us to detect the errors much earlier, and this is a efficient way to detect errors and therefore reduces cost of development and the time of development. The testing techniques have become really sophisticated. We will look at them later in this course, and there are many standard testing techniques and tools are available. Earlier the programmer just wrote the code and then never know when it will get completed. We will just have to ask the programmer how far he has done in the coding. But even if he say that I am nearly completing the code, but then he might have too many bugs and he may take years to correct them. But right now there is a visibility of the development. Somebody can see that the design is done, code is done, or let us say the requirements are done. So, these documents improve the visibility. Earlier there were no visibility, you just have to ask the programmer that how far he has done. Right now you can see the documents and determine with what stage of development it is. The increased visibility makes software project management much easier. Earlier the project manager has to just ask the programmer how he is doing, how long he is, and naturally the projects were going haywire. A 1 year project taking 5 years was not uncommon, but now due to the increased visibility the project manager can very accurately determine when the project at what stage it is and how long it will take to complete the work. Because good documents now are produced, later maintenance becomes easier. Several metrics are being used, which are used to determine the quality of the software, software project management, and so on. There are many project management techniques that are being used, like estimation, scheduling, monitoring mechanisms, and also case tools are being used extensively. Let us look at couple of review questions before we proceed further. One is what do we mean by structured programming? As we had discussed, structured programming is writing programs that do not use go tos, but only use sequence selection and iteration type of constructs and are modular. What problems may appear if a large program is developed without using structured programming techniques? Okay, the program will take long time, longer than what it should be, it would cost much more, it will have lot of bugs, difficult to maintain, difficult to understand the code, and so on. Now, we have completed the introductory topics that we wanted to discuss. Before we look at the specification, design, testing, and so on, we will just spend couple of lectures on the life cycle models, because these are one of the basic principles that we must know, and before a project starts we must know what are the life cycle models that are available, which one will suit this project, and we should be able to use this project. Or if a project is using certain life cycle model, we must be able to know that why this is being used and what is involved in the life cycle model that is being used. At a very conceptual model, we have some notion of a life cycle. A life cycle is the set of stages through which something evolves. For example, a human being life cycle involves from child, adult, old age and retired and so on. Similar is the software life cycle. Conceptually, you can think that somebody thought of the software. So, that is conceptualization. Then he finds out what exactly is needed, specification, then design the software, code based on the design, test it, install it and deliver. Then later problems are maintained, and then after some time the software may not be needed anymore, maybe because the business has changed, maybe different software have become available which are much better, or maybe the hardware changed, is no more used. For whatever reason, slowly after many years it is no more used and it is retired. Based on this intuitive idea of a life cycle model, let us look at the what exactly is a software life cycle model, which is also called as a process model, the development process model, or the software development life cycle, SDLC. Normally, we represent a software life cycle model or the process model in the form of a diagrammatic representation, just like we had represented in the earlier slide. But just a diagrammatic representation is not enough, even though it helps us to get a quick glance of what happens, what are the stages, how does the software evolve starting from conception to the final code, but it lacks details. And therefore, with every life cycle model, we not only have a diagrammatic model, but also a descriptive description of what exactly is involved. Every life cycle model should identify what are the activities through which software is developed. Maybe the requirements gathering, requirement analysis, specification, high level design, detailed design and so on. Every software is developed through different types of activities, and a life cycle model represents all these activities. And not only it represents the activities, but also it establishes a precedence ordering that which activity should be done after which one, and also divides all these activities into phases, that is which activities should take place in which phase of development. In other words, every phase of development consists of many activities. For example, the design stage activity may be structured analysis, structured design, design review and so on. But let us answer this basic question that why model life cycle? If as long as we understand that what are the activities to be done and so on, why do we need a life cycle model? Now, every development organization, they have their own life cycle model, which is a written description, graphical and also written, available in the form of books to be referred by the existing programmers, new programmers and so on. The main advantage of having such a graphical and written description, that is having a documented life cycle model, is that all developers will have a common understanding of activities that will be done, the sequence of activities and so on. Therefore, the development becomes much more disciplined. It helps to identify inconsistencies in the activities, redundancies, some activity not required, omissions, some activities required, but not there. Let us say review is not mentioned, but that is really required. So, we have to mention review in the life cycle model. And not only that, as long as we have a written life cycle model for a specific project, we can look at the life cycle model and tailor it little bit, that these are the activities which are not required, or these are some new activities that will be required for this specific project. No wonder that most of the standards now, quality standard, they require every organization which would qualify for that quality standard would to have a written life cycle model or the process model. Quality standards like ISO, ACI, etc., they all require a documented life cycle model. Once a written life cycle model is available in organization, they have identified a suitable life cycle model for the type of the projects they do. The programmers, the developers are asked to understand it fully, and they adhere, they use it rigorously. The main advantage is that the life cycle models help to solve a big problem, that as long as the problem is small, it is done by one programmer or one developer, and he does by himself whatever he needs to do. But when there is a team of developers working to solve a large problem, then the life cycle model has to be used, because every developer has to have a precise understanding of what exactly needs to be done, what the other developers are doing, what they are expecting from the development. The earlier life cycle, the earlier informal development technique that was used was the build and fix style. This can be used only when the problem is very small and is within the grasp of an individual, and he has the liberty to interpret this style. This is a very informal style. Interpret, maybe he just writes the requirements fast and very preliminary ways, does coding, test, fix, and so on. But another designer may interpret this and say that first he needs to write the code, then design, then test, then change code. Another designer might say that need to specify code, design, test. So, the developers had flexibility in using whatever style that suited to them, but when there is a team development, this kind of informal style of development would create real problem and the project will fail. In team development, there must be precise understanding of the team members, that who will do what, when, what is expected from a team member, who will supply that, and so on. Without such a disciplined life cycle model, there can be chaos and project failure. For example, let us say life cycle is not followed. One programmer writes code for some part, another is he wants to do the test document design first, another one is doing the file structure, another one is writing specification, and so on. Then this type of project is destined to failure, because they are doing very different activities. and when the specification is done by one programmer, the other programmer has already written the code and so on. Every life cycle model, as we were saying, consists of a set of phases. But then before a phase starts, certain conditions must be satisfied before the work can start, and similarly a phase, let us say a requirement phase to complete, must know what are the conditions that must be satisfied for the stage to complete. For example, the requirement document is completely written and has been reviewed by the team members internally and also by the customer. Without a phase entry and exit criterion clearly mentioned in the life cycle model, it will create lot of confusion. For example, if we do not say that requirements document is complete only after the document has been written completely and has been reviewed, different teams may interpret it differently, and some might just write it and then proceed to the next phase. Another team may say that we need to review and so on. So, for unambiguous interpretation of the life cycle model, every phase must have entry and exit criteria, that when does a phase can start and when can it end. The exit criteria for the requirement specification phase is that requirements should have been gathered, should have been analyzed, should have been documented, internally reviewed by the team members, all errors in the requirements must have been corrected, and finally, the customer should have approved the requirements. A phase can start only after the phase entry criteria have been satisfied. One of the main advantages of having the phase entry and exit criteria is that it helps us define milestones. A milestone is an important event during the development of software. For example, if the phase exit criteria is satisfied, then an important milestone is reached. The advantage of having milestones is that the project manager knows how far the project has progressed, and it becomes easy for him to plan, monitor the project, whether it will be able to meet the promise that was given to the customer about the delivery, or he has to put more manpower or outsource some part and so on. The phase start and end are important milestones, that is entry and exit are important milestones, and it helps to track the project effectively. If we do not have such milestones, then the project manager is at a loss, does not know how far the project has progressed. He can just ask the team members that how long do you think it will take, how far you have completed. But the problem is that in such guess of the team members, where the project manager has to rely on the guess of the team members, the programmers are normally very optimistic, and the programmers typically say that, see, almost done. This used to be a big problem when the life cycle model was not being followed, and this problem is known as the 99% complete syndrome. That is, whenever the project manager asks to the team member, they say that almost done, 99% done, because they are highly optimistic, but then it just keeps on taking more and more time. The project manager becomes impatient, asks why it is taking time. They say that some bug, some reason they give, something has to be changed, and so on. So, the project management without a life cycle model is very difficult and suffers from the 99% complete syndrome. But as the development proceeds, what are the documents that are produced? Is it that the code is the most important document, the most important artifact, and the only code is to be given to the customer? Not really. It is not the working program that is given to the customer, it is all the documents, all documentation needs to be developed. For example, the specification document, design document, the test document, the maintenance document, the user's manual, and so on. All these documents have to be developed during the development process. It is not just the code. Code is just one part of the deliverables. So far, we have seen some very basic concepts on the life cycle, the phases, phase entry and exit criteria, milestones, and so on. Now, we will start looking at the important life cycle models, the traditional models like waterfall, V model, evolutionary, prototyping, and spiral model, and also the modern agile models. But right now, we are just nearing completion of this lecture. We will break here and we will start from this point in the next lecture.